Here is an example of um, finding limits. So this is not a simple example on finding the limits. So we normally get the limit through substitution, and if we do the substitution, so we will see that the limit will be, so limit as h approaches 0 of 3 plus h to the negative 1 minus 3 to the negative 1 all over h will become 3 plus 0 to the negative 1 minus 3 to the negative 1 all over 0, and this will be 3 to the negative 1 minus 3 to the negative 1 over 0, or 0 over 0. So this is indeterminate. So take note, this is different to undefined, because undefined usually it's a number, a non-zero number over 0. But in the case of 0 over 0, it means you can do something with the expression, and you can try to find a way to simplify it. And once you have simplified the expression, most often than not, you can get the limit as h approaches a particular number. Now, if you look at the expression, it involves a negative 1. So my initial plan here is to rewrite this without the negative exponents. So the limit of as h approaches 0 of 3 plus h to the negative 1 minus 3 to the negative 1 over h is the same as the limit as h approaches 0 of 1 over 3 plus h minus 1 over 3 over h. So that's how we simplify expression with the negative exponents. Then, normally, whenever you see two fractions, you can combine them into a single fraction. So you can get the limit as h approaches 0. The LCD would be 3 and 3 plus h. So that's 3 times 3 plus h. When you divide this by the 3 plus h, you get 3. So 3 times 1 is 3. When you divide the LCD by 3, you take away 3. So you have 3 plus h times 1. So minus. So take note how I place the parenthesis to make sure I will not commit an error on the sign. So minus, so 3 plus h, that means parenthesis 3 plus h. This is all over h. And then further simplify the expression. You have 3 minus h over 3 times 3 plus h, everything over h. So this is 0, 3 minus 3 is 0, negative h over h, so this will become negative 1. So this is limit as h approaches 0 of negative 1 over 3 times 3 plus h. So the moment you come up with a simplified version of this expression, then you try the substitution method again. So when you substitute 0 to h, this will become negative 1 over 3. 3 plus 0, so this is negative 1 over 3 times 3, so negative 1 over 9. So that's the limit of the function. Okay, so again, for complicated expression, normally the key here is you have to simplify it. And there are many types of expressions that need different ways of simplifying them. In this case, you need to simplify this by taking away the negative exponents. So you have to rewrite them in terms of positive exponents. So this is how we simplify them. And then, as much as possible, if you have two expressions or two fractions, you can combine them into a single fraction. So simplify further until you come up with a simplified version or a reduced version, and then you go back to the substitution method. If the substitution will work, then you can already find the limit. Okay, so that's the solution for this problem, finding the limit as h approaches 0 of 3 plus h to the negative 1 minus 3 to the negative 1 over h. That's it.